Hey guys, welcome to another episode of Tinkering with Tiny Humans. We have both of our tiny humans today, Jake and Lainey.
Hi.
And today we are going to be crushing and imploding this can with nothing other than a half cup of water and some heat.
Can I get more?
No, we're not going to use a hammer to crush it. We're going to use science to crush it. Yes.
Science!
And while we're doing that, we're going to learn about some properties. So, Lainey and Jake, do you know what the word density means?
Yep. It's like
One at a time.
how heavy.
One at a time.
It's like stuff per weight.
Stuff per weight. What do you think it means, Lainey?
How heavy it is.
How heavy something is? Okay. So those involve the right concepts. Jake's is closer to the right answer. So here's a demonstration. This is polystyrene. It is a polymer of styrene monomers, and it's what people think of when they think of styrofoam. So this is polystyrene, and this is a piece of stainless steel. Stainless steel is iron and carbon and chrome and nickel. I think it's just got to have chrome, but sometimes it's nickel. So it's steel that doesn't rust very easily. So I have made both of these exactly 1/2 of an inch thick, and both of them are exactly the same size. So what do you think we can learn by picking up these two things that are exactly the same dimensions?
This was more dense.
This one is it, okay, so first off, when we say that something's more heavy, that's like a simple way of saying it has more mass, it has more matter, and it has more atoms in it. So which one of these two has more atoms of stuff in it, or more matter? Yeah, that's right. So pick it up.
I'm not.
Okay. It's very heavy, right? And this one, easy to pick up. So we know that this one is more heavy for the same size than this one. So the definition of density is the amount of matter per unit volume. And volume is the amount of space that something takes up. Does that make sense? So the amount of stuff per unit volume tells us density. The most common unit is kilograms per square meter, or grams per square centimeter. And if you use English measurements, it's really wacky, so I hope you don't have to use English measurements. But we know that this is more dense because it has more stuff in it per space than this one. Does that make sense? So more dense, less dense, because this has more atoms in it that are heavier, more matter than this does. Yeah? Okay. So you destroyed the only thing that we used for our experiment, so we are not going to be able to do that experiment until we take a break a little bit later. So we will have to hold off on doing that. So
Sorry.
it's okay. You are a destroyer of styrofoam. I should have known that. All right, so we're going to do an experiment. So we know that this styrofoam is less dense than this stainless steel. And there's an interesting thing about water. Water will tell you if something is more or less dense than it if you put it in there and it floats or sinks. So if you put something in water and it floats, it is less dense than water. And if you put something in there and it sinks, it is more dense. Yes,
Can
Lenny?
I just put the pieces of styrofoam?
Nope, I can't roll through that.
We can, yes. So let's do an experiment. I need the stainless steel nut and the pieces of styrofoam. Got the styrofoam. Okay, where is the stainless steel nut? Oh, Mr. Panda was using it as a chair.
No, he's not Mr. Panda. He's
Mrs.
Panda. He's Panda Junior.
Okay, Panda Junior.
That's and Panda Junior, the second of Panda.
Okay. You're a wackadoodle. All right, so we have a nut that is made of stainless steel, and that's the same stuff that this is made of. And since it's made of the same stuff, that means it has the same density as this.
Wait, does it?
It does.
It's not.
It's 304 stainless, and this is 304 stainless. So it should have the same density. So that's interesting, right? This is more heavy, it weighs more than this, but if you were to cut out the same shape of this from here, it would weigh the exact same because they both have the same densities. All right, so this is actually this, and this is actually this. So if we put this in the water, it's going to tell us something about whether it is more or less dense than water. All right, Jake, you first.
Wait, what if you choose two things that both float?
Then that tells you that they are both less dense than water, but it doesn't tell you which one is more dense than each other. We would have to do a different test. We could weigh it and then calculate its volume, but we'll do that in another activity.
Mr. Panda Junior, the second.
Why does the nut look bigger in water?
Oh, that's because of the diffraction of light. So when the light goes through two different things of different densities, it bends. And that's why it also looks like if you put a straw down into the water and you look at it at an angle, it looks like the straw's broken. It's
like,
because the light bends and diffracts.
So
If
you made like a
So satisfying.
if you made a person out of styrofoam, it would look like it were walking on water.
Yes, they would walk on water. So we know that the styrofoam is less dense than the water and the stainless steel is more dense than the water, right?
Yeah.
Okay, now there's one more thing that is interesting.
We've gone cuckoo.
Well, you've gone cuckoo. You are cuckoo. You are always cuckoo. You just demonstrated cuckoo-ness.
Or that's Panda Junior.
And then when I bring Panda Junior the second and Mr. And I'm bringing them.
Density changes with temperature. So even two things that are the same substance can have different densities. What are the different ways that we can observe water? What are its different forms? That was terrifying. All right, what are the different ways that we can observe? What are the different states of matter for water?
There is
Gas,
Yep.
liquid,
Yep.
and
solid.
Mm-hmm.
I was gonna say mass.
Yeah. So we are going to do an experiment with that. So we have the same substance. We've got water in liquid form, we've got water in solid form, also known as ice. And we're gonna put the ice into the water. What happens?
It floats.
What does that tell you?
It's less dense.
It is less dense. And that means for the same amount of stuff, it must get bigger. So water is a very interesting thing. It is not like most substances. It swells up when you freeze it. So ice, when you freeze it, becomes less dense, and most other things, when you freeze it, becomes more dense. And that's because it's a polar molecule. We'll talk about that another day. But here's the interesting corollary to that.
Wait, why does it melt really fast on stainless steel?
That's because the stainless steel is acting as a heat sink, and it is pulling the heat out of the ice, and it is causing it to melt. Sorry about that, I misspoke. Heat naturally propagates from a hot location to a cold location. So what I should have said is that the ice cube is pulling the heat out of the stainless steel plate, and that is what's causing it to melt. Of course, the same thing is happening when we place it on the polystyrene, but since the polystyrene is a good thermal insulator, it doesn't accelerate the melting of the ice anywhere near as quickly as when we place the ice on the stainless steel plate.
Yeah, but it doesn't melt the first one.
Because polystyrene is an insulator. So it is a thermal insulator, and this is a thermal conductor. A thermal conductor allows heat to pass through it very well, and a thermal insulator prevents heat from passing through it. There's no such thing as cold. There's just the absence of heat. So when we change phase, when we go from a water to a vapor, which is gas, the density changes a lot. So listen, this is important. This is important. This is important. When it goes from water to gas, it increases in volume by 1,600 times, which means we could take a tiny bit of water, put it inside of this can, boil it into a gas, and then put the lid on it, and when it turns back into a liquid, it's going to shrink 1,600 times, smaller than it was originally, and with it, the can will go. So that'd be pretty cool. Now there's a relationship between the volume of something, the temperature, the amount of stuff in the gas, and the pressure. And that's the pressure equation that's called PV equals nRT. We'll talk about that in another video, but for now, all we need to know is that when we increase the temperature of the water, it turns into a gas and it becomes less dense. And when we put the cap on it, it seals the container and we have the same amount of stuff trapped in there. And when we cool it, it's going to reduce its size and become more dense, and it will take the can with it. So we're gonna set that up and we'll be back with you in 1 moment. All right, see you then. All right, we are back. And all we need to do now is we're going to use this induction burner. And an induction burner uses an electric coil to actually heat up the container instead of heating up the surface. So we're going to heat up the can with this induction coil, and all we need is 1/2 of a cup of water. Why is there a panda in my water? Okay.
Stop scooping him up.
All right, it's just water, no pandas.
Panda party!
All right. Okay, 1/2 cup water. Lena, will you put the funnel into the mouth of the can, please? Okay. Got our safety glasses on. Excellent.
If you did put a panda in there, it wouldn't go down.
It would not, that's true. All right, so we've got our gloves. Excellent.
I'm gonna need the giant mitten.
Okay, so Laney, come over here. I need you to help me. So we're gonna turn on the induction heater and we're gonna wait till steam comes onto the top, and that tells us that we've been boiling. So we're gonna turn this on power, maximum, and we're gonna listen to probably hear it start to boil.
Like a...
Yeah, like a, kind of like a kettle when it's about to boil.
like that.
Yes, well, it won't whistle because there's not a restriction at the top, but we'll start to see some bubbles.
Like,
It might make some E's, yes. Yes. All right, so we have started to boil. Excellent. All right, we're gonna take our gloves. We're gonna put the lid. All right, quick, come over here. Come here, watch.
I put it in the cold water.
Ready?
No, no, with the pandas.
They'll be fine. Ready? Whoa! That is epic! Oh my goodness! That was just from the suction caused by the steam collapsing in density. Check that out! That is super cool. Lainey, check it out.
I saw it.
Yeah,
the
that's
pandas died.
The pandas totally died.
No, they like flipped out.
Now, we're gonna do a different experiment. We're gonna see if we can re-inflate this.
Oh boy.
Yes, let's give it a
Now?
try. Yeah, now. All right, Lainey, we are going to try to re-inflate it. Now, this could rupture and pop and spew steam around. So I would like you to stand right there, just for safety's sake.
What about me?
You're okay, you're farther away. So the problem is, it is not flat enough on the bottom to detect that there is enough metal there. Well, that's not going to work. I forgot that 304 stainless steel is austenitic, which means basically that it is not magnetic unless it is cold work hardened. You'll notice this if you have a fastener that has rolled threads on it. The head of the fastener will be pretty much non-magnetic, but since the threads were work hardened, that causes alignment of the poles inside of the structure, and the threaded portion will be somewhat magnetic. The takeaway here, this plate is never going to heat up on the induction burner. All right, we are going to try to reinflate the can by adding heat. We tried to use the induction burner, but it did not work, so we're going to use a torch to apply some heat here. Oh, there we go. Check it out. Inflating. Check it out. Oh my goodness. It's inflating before our very eyes. All right, I think that is about the end of what is safe, because I don't want to rupture it. But we have reinflated the can by putting heat back into the system and using steam. That is amazing. That's okay. It's okay. Now cool down again and recrush. Oh my gosh, it's doing it again. It's like a repeatable system.
What the heck?
Oh, there's a tiny hole on the side. Oh, we have a steam engine. Now steam is very dangerous because it can be hotter than 212 degrees.
So get away from it?
Yeah, I think we've used up the integrity of the can. That was super awesome. Assuming that it didn't create a hole in it, we could do this over and over again. That is so cool. All right, well, let's stop the camera and we'll talk about what we learned. I hope that that was a cool demonstration for you about density and the pressure change when we add heat or take away heat. So we decided we discovered from what we learned today that when we add heat to the system and create steam from water, it increases 1,600 times in its size. And that means that the opposite holds true, so that when that steam cools down, it shrinks to 1,600 times its original size, and that's what caused our container to crumple up. And then we put more heat back into the system and we blew it up again. So a closed system, you could shrink it and blow it up as many times as you want, as long as there's no leak. But we eventually created a little pinhole from crumpling the metal too many times.
That's why you saw that log smoking.
That is why we saw, well, that's the steam coming out of it too, and the log smoking. So what was your favorite part about the project?
I would say the pandas.
What about the science-y part was your favorite part?
I would say the fact that you could implode stuff just by heating them up.
That was really cool. Elena, what was your favorite science-y part? Hey, I have a question for you. What did you learn about the density of Lego pandas? Are they more dense or less dense than water? Yes, they're less dense because you took them for a swim in the sink and they were floating the whole time. So they are less dense than water. Very good. What do you think we should do differently next time?
I would say for Lainey not to destroy the styrofoam.
Well, yeah, I did have to get some more styrofoam. That's true.
Keep away from...
So don't let Lainey destroy the supplies. What else will we do differently next time?
Make sure the pandas don't swim in there while we're doing an experiment.
Well, that didn't hurt anything, so that's okay. Lainey needs to have a critter on every video, so she needed a panda today.
More pandas.
I would have tested our equipment better because I really don't know why the induction burner wouldn't allow us to heat it up a second time. I believe it has something to do with there's a sensor in it that detects if there's metal there or not. And when it was all warped, it wasn't seeing enough metal in contact with the burner. But that's odd because I don't know why the chunk of stainless steel didn't reactivate it. Maybe, I don't really know why. We'll have to do some experiments and figure out why that changed. So I thought that was a really cool video. If you would like us to make some more videos that talk about science and crafting and DIY projects, please like and subscribe. That'll help us get some more view counts and hopefully get us some revenue so that we can buy better gear and do more projects for you. So until next time, we really thank you for watching. Bye.